Are you ready to uncover the untapped riches of the universe? Join us as we explore the groundbreaking potential of asteroid mining for space resources. From rare minerals to precious metals, the possibilities are endless. Don't miss out on this incredible opportunity to learn about the future of space exploration. What is asteroid mining? The exploitation of raw materials from asteroids and other minor planets, including near-Earth objects. Minerals can be mined from an asteroid or spent comet, then used in space for construction materials or taken back to Earth. As the consequences of environmental degradation and natural resource depletion become increasingly severe, scientists are placing a greater emphasis on not only sustainably utilizing the resources that we already have, but also on identifying new methods of obtaining resources. For example, scientists are pursuing novel but contentious resource extraction techniques such as fracking. One particular suggested solution, asteroid mining, is literally out of this world. Although proposed many times, the first tangible effort to enable the exploration and development of asteroid mining came in 2012 from Planetary Resources, a Seattle-based aerospace company. Planetary Resources were then closely followed by a similar company, Deep Space Industries. Both groups have made significant contributions to the field, designing satellites that have identified about 15,000 asteroids with significant potential for mining. Opportunities in asteroid mining. Generally, asteroid mining remains hypothetical, mostly because of its exorbitant cost. While specific estimates of the cost of commercial mining remain unclear, similarities can be drawn between such programs and NASA's OSIRIS-REx mission, which seeks to obtain samples from a near-Earth asteroid named Bennu. Despite only being projected to return between 400 grams and 1 kilogram of material, the mission is projected to take 7 years and cost over $1 billion. Planetary Resources and Deep Space Industries were unable to finance themselves to meet such high development costs. Both companies were acquired by other businesses in 2018 and 2019, respectively. Despite the high price tag, the development of asteroid mining technology may very well be a worthwhile endeavor due to the extremely valuable resources that asteroids have to offer. For example, Aster, which measures the potential value of over 6,000 asteroids that NASA currently tracks, has determined that mining just the top 10 most cost-effective asteroids, that is, those that are both closest to Earth and greatest in value, would produce a profit of around $1.5 trillion. Further expansion. There is also great potential for further expansion. One asteroid, 16 Psyche, has been reported to contain $700 quintillion worth of gold, enough for every person on Earth to receive about $93 billion. Such technology could also have a tangible environmental impact. Most notably, asteroid mining would prevent the need for traditional in-the-ground methods of mining, which release toxic chemicals such as lead and arsenic into waterways and contribute to acid mine drainage. Asteroid mining could also provide an avenue for the creation of solar power satellites, a potentially consistent source of clean energy. Most of the progress that has already been made on asteroid mining technology has been focused on extracting water, reflecting concerns about growing water shortages around the world. Additionally, an important argument can be made that asteroid mining would reduce the prevalence of inhumane or otherwise illegal practices surrounding human mining operations. This would especially impact artisanal and small-scale mining, ASM, operations that are not managed by larger mining companies. For example, recent attention has been focused on the Democratic Republic of the Congo. This country has responded to the growing global demand for batteries and electric vehicles through its cobalt supplies, of which it contains about 70% of the world's resources. Although mining operations can be dangerous, a deplorable record of child labor and fatal accidents within Congolese ASM operations has highlighted the need for significant change. Asteroid mining as an alternative to traditional mining might be the kind of change the world requires to end these abuses of power. Economic impacts. Perhaps the most apparent impact of asteroid mining would be on the global economy. On one hand, it could produce significant wealth for individuals, with astrophysicist Neil deGrasse Tyson among others, even claiming that the first trillionaire will be an asteroid mining mogul. To this end, some argue that promoting asteroid mining technology could also be the key to developing a future space economy, ranging from tourism to settlement. However, many experts argue on the flip side that asteroid mining would quickly destroy the economy of global raw materials, currently valued at about $660 billion. They claim this economy would be quickly overtaken by the quintillions of dollars worth of material from asteroid mining. Asteroid mining resources would flood the market, causing a rapid devaluation of global raw materials. Such a situation was simulated by researchers at Tel Aviv University. They predicted that a significant global struggle for resources and power would ensue in a world with asteroid mining. They came to this conclusion after creating a simulation in which one shipment of space minerals devalued the price of gold on Earth by 50%. Notably, the Tel Aviv researchers also predicted that within this struggle, developing countries would be significantly affected because they heavily rely on mineral exports and do not have the resources to build their asteroid mining operations. This perspective has not been extensively covered in the existing literature on the economics of space mining, but could be a real possibility. Specifically, asteroid mining might allow one company to become responsible for the trading of a single natural resource, threatening countries that presently rely on resource exports. For example, some individual asteroids possess upwards of $50 billion of platinum. South Africa. In comparison, South Africa, the largest producer of platinum at about 72% of the world's supply, mined only about $3.8 billion worth of platinum in 2018, or 4.3 million ounces at an average price of $882.18 per ounce. South Africa has greatly benefited from the use of its platinum resources, as well as its many other mineral resources, with the industry employing over 451,000 people and comprising 8.2% of its GDP. In a future where asteroid mining becomes the norm, South Africa's economic performance would shrivel, harming the livelihoods of many South Africans. The situation is likely to be even direr in other countries. Unlike South Africa, which has a fairly large and diverse economy and a budding space industry, Zimbabwe, another major platinum producer, would struggle substantially more if mining operations were overtaken. Zimbabwe would be especially affected given that the nation currently does not have the resources to develop space mining technology. With research efforts underway to determine the number of other elements, including cobalt, on different asteroids, a wide variety of fledgling economies are at risk. For example, the possibility of obtaining cobalt from asteroids could wreck the Democratic Republic of the Congo's cobalt mining operations. This would ultimately damage the nation's entire economy. In conclusion, asteroid mining is a groundbreaking technology that has the potential to revolutionize the space industry and bring about unprecedented economic and scientific benefits. With the help of organizations like the Commercial Spaceflight Federation and the Coalition for Deep Space Exploration, The dream of harvesting precious resources from celestial bodies is no longer a distant possibility, but a very real and exciting prospect for the future. Don't forget to subscribe to our channel, or you will miss out on our interesting videos.